So we will start the amplitude modulation. We'll start from the what is modulation, and then we will go for the amplitude modulation, the detail, the mathematical analysis of it. Now, in the modulation, here, this is what the definition of modulation. What is modulation? So modulation, you can say, in the modulation process, some characteristics of the high frequency carrier signal is changed according to the instantaneous amplitude of the information signal. So here you can see this signal is a modulation signal. This is what the normal signal, and this is high frequency signal. So as compared to this signal, the amplitude of this signal is adjusted. This is called modulation. Now, why it is required? Because we need uh, the communication will be between two antennas. So it is in the space, electromagnetic wave. So here we need an antenna. So reduce the antenna height is a one parameter. Multiple signal you can transmit at a time. So for the multiplexing, you need this modulation. Then the whatever the capacity or inductive device require high frequencies. So here we are using the high frequency signal and suitable for the noise rejection. The noise which is generated in the nature is comparatively in a low frequency. And if we will use the high frequency, it may not affect the high frequency signal. So this is the modulation and need of modulation, what we are doing. Now we will go for the signal, as we require the prerequisite for this is the signal and system. Now, here this is what the representation of the signal. The V equals to Vm sin omega t. And here A max or A minus A max. So sometimes it is represented by V max or sometimes A max. So that's why in figure I have given this notation. So here this is what the nomenclature or the signal representation that you are aware simply. Now we will go for the AM generation. How AM signal, that is amplitude modulated signal, is generated. So the amplitude modulated signal is generated. Here, this is what the mixing, that is multiplying the normal signal. Generally, this is amplitude, this is what modulating signal. Generally, we take the sinusoidal signal, but here this signal, actual signal is shown. Not necessary that every time the signal is the sinusoidal signal, it may be anything. But for the understanding, this signal is taken. And here is the oscillator, that is called FC, high frequency signal. So these two are mixed and this signal is generated. Now, how it looks like? This is what your sinusoidal signal. This is what your high frequency signal. It is multiple times of your this is what modulating signal. And this is what the modulated signal. So this high frequency signal, what we have done in the amplitude modulation, high frequency signal here, it is having the constant amplitude and constant frequency, particular frequency. Now frequency we have not changed, we have not done anything with the frequency, but the amplitude of this signal we have changed according to the modulating signal, this one. So this signal, this modulating signal, it is shifted vertically upward. That is called DC offset. So this DC offset is given and then it is given this way. And this is also the DC offset. So this is creating an envelope. So actual, you can have the upper signal, this one, or the lower one. So this is the same signal. You are getting a replica in the positive or the negative. So this signal is called amplitude modulated, that is AM, double sideband full carrier. So this it is having two sideband. I'll explain further how the sidebands are there in frequency domain. And full carrier, the carrier here is the full. So for the other purpose, we can suppress the carrier, we can suppress the one of the sideband and all this. So that we'll discuss afterwards. So this is way it is generated. Now, one of the basic parameter for the amplitude modulation or any modulation is the modulation index. Now, this modulation or the modulation index or the percentage modulation, what is that? So what it is used to describe the amount of amplitude change, that is the modulation in terms of the percent in the AM. So this is what one of the parameter which will give you the understanding what is the quality of your amplitude modulation wave, one of the parameter. So it may be taken in the percentage, or if it is simply M, so it is called modulation index, or if it is in percent, then it is percentage modulation, you can see. So here, how it is given. So this is what the more specifically the percentage modulation give the percentage change in the modulation of the output wave when the carrier is on the modulating signal. Means what? We will do the mathematical analysis for this, and we will solve simple numerical on this also. Now, what is this modulation index represented by M? So the formula is M equals to EM by, it is EM by EC. Okay. So the modulation index is EM by EC, and percentage modulation is EM by EC into 100%. Now, what is this EM? So the M is the modulation index. EM is what? Your peak change in the amplitude output wave, that is sum of the voltage from upper and the lower side frequencies. I'll show you what is this EM in the waveform, so that here somewhere it is called EM or VM, one and same thing. So EC is the peak amplitude of unmodulated carrier. So you have the unmodulated carrier and you have the modulated. The EM is the peak change in the amplitude output waveform, that is sum of voltage upper and the lower sideband. What is it? So this is the modulation index. Here, this waveform is a representation of under modulation. That is, this is your line, and these waveforms are away from your horizontal line, that is your reference line. So there is a gap. So here M is less than 1. How it is less than 1? We will calculate. Here they are touching exactly. So here M equals to 1 or 100%. So this is what perfect modulation. And here this is called over modulation. That is, this waveform is going in the negative side, and the negative side waveform, it is going in the positive. So there is an overlap between two waveforms. So due to this overlap, whatever the data you have here, it will get lost. Whatever the data you will have here, that data will get lost. So what we can see, yes, uh, any question, Raj?
सर थोड़ा आप जोर से बोलिए ना, आवाज बहुत धीमा आ रहा है.
Okay, I'll use the now it is okay.
Yes, sir.
Okay, thank you. So what we will do here in the over modulation, here there is a loss of data. Okay, whatever the data you will have, it will get lost. So that's why it is not recommended, because what you are transmitting, there may be a break or flickering in the voice if it is the voice data. So this is not recommended. Perfect modulation, obviously, yes, it is there, but it is difficult to maintain. And you can have, okay, under modulation is okay, no harm in the data or transmission, it is okay. So practically this under modulation is preferred, but only the disadvantage is here the power consumption in this under modulation is more. So we will try to go to the perfect modulation, but not the over modulation. So over modulation, if you will go in over modulation, you will lose the data. So this is what practical aspect of this under modulation, over modulation, and the perfect modulation. Now we'll go for some graphical representation and how it is there. So here we can check that whatever the things, that is, this is what your envelope, upper waveform, and this is the replica lower waveform. So here we will see what is that. Now, this is what one line it is drawn. So this is EC. EC means your carrier. C stand for carrier. So this is your carrier frequency, the amplitude of carrier frequency. If you will have a carrier frequency, so positive EC and this is negative EC. Okay. Then above that, it will have some peak. So this is EC plus EM. Where is your EM? So this is from this point to here, this is what your EM, the modulating signal. So below this, it is EC and this is EM. So this plus Vmax, it is EC plus EM. This is reference line T. Above this, it is EC and here EM. I will use some different colors so that this is what EM and the lower one, this is what EC. So the total from here to here, it is V plus Vmax, EC plus EM. Simple concept. Now, what is above this horizontal line, whatever this small portion, it is Vmin. This is Vmax and this is Vmin. So this Vmin equals to EC minus EM. This is EC minus EM. We are doing the subtraction. So this is plus side. So this is plus Vmax. This is minus Vmax. It is on the negative side. This is minus Vmin. Again the same. So it is minus EC. EC is in negative side. Minus EC plus EM. So subtraction of these two. Again minus VM. Both are on negative side. That is EC minus EM. So same thing, only these are on the negative side, so signs are changed. So this is what we have analyzed the waveform. Now we will calculate the modulation index based on this waveform. So what is our formula for the modulation index? So that is modulation index is your, here is the formula, that is EM by EC. Now EM we have calculated and EC. So again we will. So the modulating signal is a pure signal, and how we can calculate. So EM equals to 1 by 2 Vmax minus Vmin. This is what you can calculate from the previous diagram. And EC equals to 1 by 2 Vmax plus Vmin. Okay. So this formula, again modulation index, we have EM by EC. So you can put this in EM value here and EC value here. So if you will simplify it, so it will be simple Vmax minus Vmin upon Vmax plus Vmin. So modulation index in the practical view, it is coming Vmax minus Vmin and then Vmax plus Vmin. Now based on this, we will solve simple problem so that we will understand whether it is a over modulation, under modulation. So accordingly, you just tell me. So I'll give a simple example. So here Vmax is 5 volt, Vmin is 0.5 volt. So can you just tell me whether what is the modulation index M equals to quickly? So what we can write a formula. Formula is this one. What is this? Vmax
4.5.
Sorry.
Sir, 4.5 upon 5.5.
4.5 upon 5.5. So it comes
It's
0.
only there, sir.
0.818. So it comes 0.818. 4.5 upon 5.5. So it will be less than 1. So if it is less than 1, so whether it is over modulation or under modulation, it will come
Under modulation.
under modulation. Why under modulation?
Because if it is more than 1, then maybe I guess it is over modulation.
Yes. So it comes 0.818. So that is, it will be what? It will be
Over modulation.
no, it is not over modulation. It is under modulation. Why under modulation? It is 4.5 divided by 5.5. So it is answer is 0.m. m equals to 0.818, 4.5 divided by 5.5. So it comes 0.818. So 0.818 is less than 1. So it is under modulation. Got it? Simple concept. Okay. Now I'll go for the next. Now you tell me for this. Vmax equals to 5 and Vmin equals to 0. So what is formula? Vmax minus Vmin upon Vmax plus Vmin. So 5 minus 0 upon 5 plus 0. So 5 by 5. 5 by 5 equals to
Perfect
1.
modulation, sir.
It is
1. Perfect modulation.
perfect modulation. Correct. So this modulation is perfect. Why perfect modulation? Here m is whatever your m is equal to 1. If it is equal to 1, then it is perfect modulation. Now, can you tell me any example for, can you give, anyone can give me a value for over modulation? Suppose my Vmax is 5 volt. So what should be my Vmin?
सर माइनस में
Less
होना
than
चाहिए.
Vmax. Less than Vmax.
Less than Vmax, मतलब 4 वोल्ट लिया चलेगा?
हाँ सर चलेगा.
करके देखो. Suppose Vmax equals to 5.
नहीं सर माइनस में होना चाहिए.
हाँ, yes, correct.
माइनस में होना चाहिए.
Absolutely correct. It should be in minus. So अगर माइनस में होगा तो ही आपका फॉर्मूला में वैल्यू पुट अप कीजिए. So this is one of the example. There may be the multiple. So Vmax equals to 5 volt and Vmin equals to minus 1, minus 2, whatever it is. So minus 1 volt. So what it will be there? 5 minus minus 1 upon 5 plus minus 1. So 5 minus minus 1 is कितना हो जाएगा? 6 and 5 plus minus 1. So it is 4. So it becomes 6 by 4. So 6 by 4 is how much? 1.5. Okay. 1.5. 6 by 4 is 1.5. So for 1.5, whether it is under modulation or over modulation?
Over
Over modulation. So you can have any example. So it will be the over modulation. So these are the simple example I have given. Formula you remember if
Sir.
it is given. Yes.
सर अगर हम Vmax अगर 5 वोल्ट ले एंड Vmin अगर 4 वोल्ट ले तो सर तो 9/1 होता है. तो 9 अगर आया तो सर ओवर मॉड्यूलेशन हो गया ना वो तो.
नहीं बेटा, 9/1 Vmax कितना है? 5 वोल्ट.
हाँ सर.
एंड Vmin
4 वोल्ट.
4 वोल्ट.
यस
तो
सर.
9 upon कैसा 1/9 होगा?
तो 5 + 4 upon 5 + 5 - 1.
नहीं, 5 minus 4. Vmax
हाँ 5
minus
- 4.
Vmin. फॉर्मूला
हाँ
ये
सर.
है. फॉर्मूला इज दिस वन.
हाँ सर
Vmax.
वैसे ही किया मैंने.
हाँ.
तो 1/9 आएगा ना,
ओके,
तो
got it,
0
got it,
आंसर आएगा.
इसमें देखिए, आपको यहाँ ही मैं करके दिखाता. We'll do this one. You can tell me the
गॉट
value.
इट सर. मेरे को लगा सर प्लस ऊपर था सो मैंने.
हाँ, ऊपर का प्लस नहीं है, फिर भी हम करते हैं. ओके. हाँ. नाउ Vmax कितना है आपका? 5. ओके. एंड Vmin 4. ठीक है. Vmax equals to 5. Vmin equals to 4. ओके. सो क्या होगा ये? Vmax minus Vmin कितना हो गया?
1
m equals to 1. 1 by कितना होगा?
9
9. 5 plus 4. 1 by 9. 1 by 9 is always
0.11.
so it is less than 1. So it will be under modulation or over modulation?
Under modulation.
Under modulation. Correct. So this way it is there. Okay. So you got the concept. So we have taken the example by all three model, that is over modulation, under modulation, and perfect modulation. So these three are the simple example of over modulation, under modulation, and perfect modulation. एक मार्क के लिए ऐसा क्वेश्चन आ सकता है. सिंपल. इट इज वेरी सिंपल. फॉर्मूला पता है तो इजीली यू कैन अचीव द मार्क्स. नाउ we will go for the mathematical representation of AM wave. तो सिंपल एक कंसेप्ट है. सो कैरियर इज रिप्रेजेंटेड. थोड़ा सा अभी सिग्नल सिस्टम के बेसिक कंसेप्ट लगेंगे. इन साइनोसाइडल ट्रिग्नोमेट्री थोड़ा ज्यादा है. So EC, carrier waveform, is represented by small EC. Capital EC is the amplitude. So EC sin omega t, ये किसका है? Carrier, high frequency signal. Where what is omega c? Omega c is the angular frequency, is represented as 2 pi fc. ठीक है? And f is the frequency of a carrier signal. fc always ये notation constant रहेगा throughout the subject. fc is for the carrier frequency. Okay. अभी modulating signal. So modulating signal के लिए em. Okay. Modulating का m लिया है, small em equals to capital em into sin omega mt. Small em, that is what representation of sinusoidal, representation of modulating signal. And omega m, what is omega m? Omega m equals to 2 pi m. Fm equals to frequency of modulating signal. So दो equation है, because we are playing with two waveform. One is carrier waveform, so this is the carrier signal, and another is the modulating signal. This is modulating signal. Now we will mix these two signal, and then accordingly we can do. So there is a question in the chat, what is modulation? So modulation is a simple process that low frequency signal we are superimposing on a high frequency signal. Low frequency signal, suppose my speech, I am speaking something, but if I want to use this, that is a mobile phone, so I want to speak. So I am speaking something. So what this mobile is doing, not amplitude modulation, any other modulation is doing, but we consider the, as we are saying, amplitude. So my voice signal is superimposed on a high frequency signal. Whatever the frequency for 2G, it is 900. For 3G, it is in gigahertz. In 5G right now, what 4G we are using, that is 5G, that is around 6 gigahertz. So this is high frequency carrier. Now my speech, what I will speak, that is in few kilohertz, maximum 3.4 kilohertz. Your speech frequency is from 300 hertz to 3. I'll just clear this. So my whatever the signal I will have, that is what speech signal 300 hertz or 300 to 3.4 kilohertz. Now what this signal is superimposed on the high frequency signal. Okay, and then it is transmitted. Same example as if you are coming to college. So what you are taking a vehicle, and then you are leaving a vehicle and coming in the classroom. Same thing, my any speech signal. Now the example I am giving the speech. So speech signal is superimposed on a high frequency signal. Go to the I am transmitting. Go to the receiver. Receiver. Suppose I am doing the phone call. At your end, it will remove the high frequency signal and audio is recovered. This is the simple concept. And in the amplitude modulation, we are changing the amplitude of high frequency signal. So that's why it is called as amplitude modulation. Got it? Or any other clarification required?
So
Shivam,
repeat.
Shivam, have you got it? Yes. Okay. Now, what you are saying? Repeat. So here only high frequency signal we are superimposing the low frequency on high frequency. This is high frequency, high speed vehicle that you are coming to the college. Okay. Now you are sitting in a vehicle, maybe the bus, train, whatever it is, it will go by high speed and reaching here. You are coming here outside the college, leaving the bus and coming inside the college. So transportation of which who's required? A person. But what you are taking a vehicle, bus. Similarly, transportation of what is required? A speech signal. So what I am speaking should be transmitted. So what I am taking a vehicle. What is vehicle? High frequency signal. And it is going at the transmitter. I am doing a phone call to you. Now here it will do the modulation and then it will go to the receiver. There are so many processes. We will not go in detail. At the receiver, he will receive a phone call. In the phone, the modulation is the high frequency signal is removed. It is called as demodulation, and then you hear the voice, whatever I speak. Now, is it clear? Further, any clarification is required, then you can let me know. I'll give it. Okay. So here now we are having, now we'll go in a mathematical representation of your amplitude modulation. So in the amplitude modulation, there are two signals. Which signal? One is this carrier signal, and other is what? Your modulating signal. There's some in it. Here I have shown here very first. ये कौन सा सिग्नल है? दिस सिग्नल इज व्हाट योर मॉड्यूलेटिंग सिग्नल. इसका एक वेवफॉर्म है, इसका एक इक्वेशन है, एंड दिस इज व्हाट कैरियर सिग्नल. एंड we have to generate equation for this mathematical equation. Why we have to do this? Because we have to analyze, we have to improve the quality, we have to understand. So that's why mathematical analysis is required. So understood? This is what one signal that is called modulating signal, low frequency signal. That is what I am speaking. This is high frequency continuous signal. As mobile, I have given an example for 5G. It is in gigahertz, maybe 6G के range में है. And this is what the generated. Now what we are doing? We are trying to generate the what? We are trying to generate this signal. इसका mathematical formulation बना. So that we want to do. So that we are doing. Now we will do that. So this is what your carrier signal, and this one, this is what your modulating signal. Now what do we will get mix. Now what is modulation process? A modulation process, this is what carrier generator. It is generating high frequency signal. ये high frequency signal generate करता है. This is carrier, maybe any oscillator, and this is modulating. जैसा मैंने example दिया, speech. I am speaking something. So this may be the speech, this may be the data or anything else. So जो हमको transmit करना है. So this is modulating signal. Now these two signals we are mixing and we are sending this amplitude modulation. This is amplitude modulator. So amplitude modulator will give this output and it is sending. Now we have equation for this, we have equation for this. Now we want to generate equation for this. That is modulated signal. That is simple. Okay. A modulation process in which amplitude of the carrier is varied. इसका क्या vary किया है? Amplitude. किसके according? In according with the instantaneous value of the modulating signal. ये क्या है आपका? This is the modulating signal. So according to this modulating signal, amplitude of this carrier signal is varied. So it is put here. लेकिन it is not put simply. ये अगर ऐसा ही यहाँ पे, it is difficult to put the high frequency signal in between. So what is done? This signal is taken and it is given a DC offset. थोड़ा ऊपर ले, तो ऊपर में भी आपका एक सिग्नल जनरेट हुआ और नीचे भी हो गया. So this is actual signal, this one with some DC offset here, and this is the replica of your modulating signal, जो mirror image. Now can anybody tell me whatever this waveform I am showing, whether it is under modulation, over modulation or perfect modulation, and why?
सर अंडर मॉड्यूलेशन है ना
हाँ, क्यों है राज अंडर
सर?
मॉड्यूलेशन?
वो जो लाइन है वो लाइन पे टच भी नहीं है, टच रहता तो परफेक्ट
Yes,
रहता,
correct,
और
correct.
नीचे से रहता तो ओवर रहता.
Perfect. So by seeing that, we can see. So this is whatever horizontal line, reference line, time axis. It is having gap between time axis, upper and lower. ये gap यहाँ पे है. So this is what the signal. Give me a minute. Okay. Now this is what AM wave expression. जो हमने लिखा है Vm, this is AM wave is expressed by the following equation, that is VAM. Now we are talking this waveform. This is given as A sin omega t, omega c. This is what the carrier signal. Now we can just go for understanding this. So what A here, what is this A? So that we will understand and then we'll put. So this A is the addition of VC and VM. Two things are there, carrier voltage and VM. This VM is small VM. So small VM is we have represented here small VM. It is EM or VM, one and same thing, somewhere EM, somewhere VM. Okay, so it is represented, if it is EM, so EM sin omega mt, or VM कभी कभी VM भी represent करते. So I am using both the notation. So this is VC, that is actual voltage, and this is small VM. So it is the entire waveform. We are taking carrier voltage and this is a modulating signal. So VC as it is, क्योंकि it is voltage, equals to plus VM, ये capital VM, तो amplitude, capital VM sin omega mt. Okay, so this is what the A. Now actual AM का equation क्या है? Just now I given, this is I given, that is VAM equals to A sin omega t. This is the representation of this. What is value of A? Just now we have calculated. This is the value of A. Now put the value of A here. So whatever the value of A we have calculated, we'll put in this equation. So what is VAM? This is VC plus VM, VC plus VM sin omega t VM into sin omega CT. Okay, तो ये आपका इक्वेशन मिलता है. So this is the equation for AM. इसको थोड़ा simplify करते हैं. What you can take VM outside. So VM equals to 1 plus VM by VC sin omega mt into outside bracket sin omega t. Okay. VM by VC क्यों किया है? क्योंकि हमको पता है इसका notation. What we know, VM by VC is what? Modulation index. Just now हमने calculate किया. So VAM equals to VC plus 1 plus M sin omega mt. Modulation index भी आ गया. So your output, this waveform is depend on modulation index sin omega t. So modulation index is also represented in this waveform. Modulation index here is less than 1. If it is touching to this line, equal to 1. If it is intersecting the line, more than greater than. So AM is representing this waveform. So AM equals to VC 1 plus M sin omega mt sin omega t. So this equation you will require, or the 8th one also. So here some of the formulas are required, essential. May you require this to solve some numericals. Okay. Let M equals to, what is this M? We know. That is VM by VC or EM by EC. Okay. Be the modulation index. The value of M is less than 1 to avoid the distortion. So what we are doing, we are taking value of M is less than. Okay. So equation 7 can be written in terms of these frequencies. So this VM equals to, it is, you just open the bracket, that is this VM sin omega t, okay, and plus this M into VC अंदर आएगा, VC sin omega mt and sin omega t. Same equation, only I have opened the bracket. ये bracket open करिए and simple equation करिए. That is VC sin omega mt plus VC sin omega mt into sin omega CT. Omega C is carrier frequency, omega M is modulation frequency. Okay, so ये equation आपका होगा. Now what is further we can go. This expression represent the time domain representation of AM wave. जो expression हमने लिखा, that is time domain. There equation 8 get simplified by using the expression. So this is trigonometrical formula we know. थोड़ा simplification करने की कोशिश कर रहे हैं. So what we are doing, 2 sine A, that is into sine B. This is trigonometric formula. 2 sine A into sine B equals to sine A plus B plus sine A minus B. This is what in 10 plus 2 you might have used in mathematics multiple time in integration derivative and simplified the equation. So same thing we can use. So here what equation we had, this is the equation number 8, that is VAM VC sine omega mt plus AM VC sine omega mt into sine omega ct. So we can simplify this multiplication sine ka. So I'll put this factor as VC sine omega ct. This is as it is, and ये जो है 2 times नहीं है तो ये 2 यहाँ पे जाएगा 1/2. So it becomes 1/2. The one factor here is this. So MVC sine A plus B. So sine का ये factor है, that is VM and VC. Sorry, omega M and omega C. So omega M plus omega C plus omega M into T. T दोनों में common है तो outside bracket. Again 1/2 M VC sine omega M. This is omega M minus omega C minus omega M into T. Okay, omega M is higher, so omega M minus omega C minus omega. So this is simplified form. Okay, so the result of the amplitude modulation wave consists of 3 terms. अभी ये क्यों किया है? Why we have done this? Here एक यहाँ पे एक लाइन लिखा है मैंने. व्हाट इज द इक्वेशन 8? इट इज इन अ टाइम डोमेन. और मुझे क्या करना है, आई वांट टू सपोज आई वांट इन अ फ्रीक्वेंसी डोमेन, तो उसके लिए दिस रिप्रेजेंटेशन. नाउ इन दिस फॉर्मूला देयर आर 3 थिंग्स, 3 फैक्टर है. कौन से फैक्टर है? सो दैट विल सी. द फर्स्ट टर्म, इसमें का पहला टर्म, द फर्स्ट टर्म इज अंडर मॉड्यूलेटेड कैरियर वेव, that is FC equals to omega C by 2 pi with amplitude EC. So this is what the first term. You can use the notation. So the first, this one I am saying. So the first one is this. Okay, here amplitude इसका VC या EC है, and what is it? It has the amplitude, this one omega C. Then the second term is the upper band, FC plus FM. ये FC plus FM, it is in normal frequency mode. Omega is the angular frequency. So this is what the second one. The second one is this term, and this is what your second term. Omega C plus omega M. ओमेगा सी प्लस ओमेगा डिवाइड बाय 2 पाई, मतलब उसको एफ में कन्वर्ट कर लिया फ्रीक्वेंसीज में. सो एंगुलर फ्रीक्वेंसी और नॉर्मल फ्रीक्वेंसी इट इज ओके. सो ओमेगा सी. सो विथ एम्पलीट्यूड, अभी इसका एम्पलीट्यूड क्या है? दिस वन 1/2 MEC. ये कहाँ है एम्पलीट्यूड? हियर इज एम्पलीट्यूड. ये जो है दिस पार्ट 1/2 MVC. तो डायरेक्ट अभी फ्रीक्वेंसी डोमेन का रिप्रेजेंटेशन में बता. इसका एम्पलीट्यूड है 1/2 MEC एंड ये क्या है? तो ओमेगा सी प्लस ओमेगा एम. सो यू कैन से FC प्लस FM, मतलब कैरियर फ्रीक्वेंसी प्लस मॉड्यूलेटिंग फ्रीक्वेंसी. एंड थर्ड कंपोनेंट, आपका थर्ड कंपोनेंट क्या है? सो थर्ड कंपोनेंट ये होगा. दिस इज द थर्ड कंपोनेंट. व्हाट इज देयर इन थर्ड कंपोनेंट? दिस ओमेगा सी माइनस ओमेगा. So omega C minus omega M by 2. So this is what the third component with amplitude, same amplitude 1/2 M EC. Okay. So इसका amplitude this one 1/2 M EC. इसका amplitude 1/2 MEC. This is called FC plus FM. इसको कहाँ है? FC minus FM. And this is FC. What is FC? Anybody can quickly tell me what is FC? Quickly.
Carrier frequency.
Carrier frequency. What is FM? FM,
modulated frequency.
modulating frequency, modulating signal, input signal हो जाए. So two frequencies are there, FC and FM. तो इसके तीन कंपोनेंट हो गए. एक हो गया FC, एक सेंटर फ्रीक्वेंसी. So if I'll represent the frequency, तो it will become this way. एक हो गया मेरा FC, सेंटर फ्रीक्वेंसी. This is FC. This is frequency reference लिया है मैंने. So this is one first component is FC. FC का amplitude कितना है? VC. Okay, here is VC. इसका amplitude VC. Okay, और MC. दूसरा कंपोनेंट क्या है? FC प्लस FM. तो पॉजिटिव एक्सिस में आपका ये आएगा दूसरा बैंड FC प्लस FM. उसका एम्पलीट्यूड कितना है? 1/2 MEC. तो इससे कम रहेगा. तीसरा क्या है? FC माइनस FM. तो वो लेफ्ट साइड में FC माइनस FM. ये क्या है आपका सेंटर का? FC. दिस इज FC प्लस FM. दिस इज FC माइनस FM. तो ये आ गया एंड इट विल बी दिस वे. तो ये आपका the second one. I'll show the waveform. Okay, so this will become the 3-band representation. आपका ऐसा representation होगा. So this will be the representation. So same thing what I showed, ये repeat किया है formula and these are the band. यहाँ पे again I am showing the same thing. What is this? This is what VC. So the first part is VC. तो ये VC and ये plus हो गया. ये आपका FC plus FM and this is minus negative the side band, lower side band. So what here we can see there are two side bands. One is called upper side band. This is FC plus FM and one is called lower side band which is FC minus FM. दोनों के amplitude. So what we have done? We have started from the time domain representation or then we have represent this and what we have represented in the frequency domain. There will be question. इसका question आता है. Mathematical representation of the amplitude modulation signal in frequency domain. So you just show this waveform and ये previous equations को justify करो by using this simple formula. ये formula use करके you have to elaborate this equation 8 to 9. उसके 3 factor है. Mention 3 factor. Draw this diagram. That's it. You will get 5 marks. At least 5 marks के लिए तो ये question answer. So that is very simple. So we are talking in the time. Any doubt here? कुछ doubt है इसमें? It is simple, nothing great. Okay. So then I'll just quickly finish this mathematical representation and analysis of AM. So here, this way, these 3 components we have given. So if M is 100%, so you can replace this M by 1. So you will get this, their representation. And the spectrum आपको दिखाना है. So quickly I'll say from the equation it is observed that the amplitude of a carrier is unaffected by the modulation process. The amplitude of the side frequency depends on the both the carrier amplitude and modulation index. So that we have shown here at 100% modulation M equals to 1. The amplitude of the side frequency are each equal to 1/2 of the amplitude of carrier. Okay, M VC by 2, M VC by 2. M is 1, so it is VC by 2. So this is what the simple representation. This is understanding. The AM modulation is a non-linear device. Okay, so this is what non-linear mixing result in the complex output envelope. So mixing is non-linear. So complex output envelope होता है, consist of carrier frequency and sum of FC plus FM and difference FC minus FM. So two frequency component are there. Always we know that in signal system you might have studied, if you will mix two frequencies, so it generate a complex frequency, and complex frequency has the two part addition and subtraction. So here also it is generating FC plus FM, FC minus FM. So the cross product are displayed from the this carrier frequency, and waveform, this signal is here. So you can represent this equation. Frequency spectrum on a AM. So this is what represented here. FC plus FM, FC plus FM, FC minus FM. This is called lower sideband frequency. This is called upper sideband frequency. This is called Calic. So when your signal transmit amplitude modulated full carrier with both the sideband, so it carry this much frequency range. That is यहाँ से FC, suppose FC is your maybe 500 kilohertz, समझो है example. If it is 500 kilohertz and your modulating frequency is 50, so 500 minus 50, so 450 से start होगा, and 500 plus 50, so 550. So it will transmit the complete band 450 to 550. What I am giving example, the modulating frequency is 50 hertz, carrier frequency is 500 hertz, for simple understanding. So when you will transmit a signal, it has this complete band. This is called lower sideband. This is called upper sideband. आगे हम देखेंगे that only lower sideband हम send कर सकते हैं क्या? Then yes. Only upper sideband कर सकते हैं क्या? Then yes. What is the advantage of that? That we will discuss later. So this is what the simple this, and bandwidth also I'll explain. So bandwidth equals to, just now I explained the bandwidth, that is FC plus FM. This is what one side, FC minus FM another side. So what will be the band? So FC plus FM, FC minus FM, band हम ऐसा निकालते. So FC will get cancelled. So here 2 times FM. So whatever your carrier, whatever your modulating frequency, double of that you will require a bandwidth to transmit amplitude modulation signal. Suppose I want to transmit a speech signal. So my speech frequency is a maximum is 3.4, 300 hertz to 3.4 kilohertz. Double of 3.4 kilohertz, that will be the minimum bandwidth I will require to transmit my speech signal over the amplitude modulation. So this is what the bandwidth. So this example we will discuss next time. So example can need to be considered, and if there is any doubt, you can ask. So your bandwidth till now we have finished. Next time what we'll do, we will consider the examples. Any doubt is there?